One of the remarkable things we find as scientists look out at the universe is that there are a large and growing number of ways that we find the universe is actually finely tuned to support life. And this fine-tuning is evidence of design and therefore of a designer. Well, one of the ways that this fine-tuning shows up is maybe a little bit non-intuitive. It actually turns out in the dimensions of the fabric of space-time in which we live. Now, just to kind of give a little bit of background, bring everybody up to speed, when we're talking about the dimensions in the universe, you got to realize that we live in a universe where you actually have to specify 4 pieces of information because we live in a universe with 4 different dimensions. We have 3 spatial dimensions. So if you want to specify where is Jeff Zweerink right now, you would have to say, all right, he is at this distance along this axis, and this distance along this axis, and this distance along this axis. So you got length, width, height, but that would not be sufficient. You also have to give one more piece of information. You have to give the time where I'm there, because if you say yesterday and I'm here today, you would be wrong. So we actually have 3 spatial dimensions, length, width, and height, and 1 time dimension. And so when we look at these dimensions, and we can now begin to ask the question, what would the universe be like with different dimensionality? Now, the first and easiest way to do that is to say, what happens if we change the number of spatial dimensions? So we live in 3 spatial dimensions, or we have 3 large spatial dimensions. Let's ask the question, what happens when we get rid of one of them? And an illustration that I think shows some of the problems that you encounter is just imagine, some large animal, a wolf, a cat, dog, whatever, something out in the wild. And these animals were going to go out and they're going to eat. They want to eat. And like any other organism, typically the food as it comes in wants to be expelled from a different location so that it doesn't have to pass back through the same way that it's eaten. And so food will come in, go into the stomach, be digested, and be expelled from a different part of the body. Now in 3 dimensions that works beautifully, but if you go down to 2 dimensions, the process of having a port to eat, a stomach, and a port to expel the food that are different, that process has now cut that organism in half. And so, say, well, okay, maybe you could get around this by having it to where the animal eats and expels out of the same thing. Okay, you get around that. It turns out it's actually a more fundamental problem. That when you look at how complex of a structure can you build in a 2-dimensional system, it's just very limited. It turns out there is not the complexity that life would require in anything less than 3 spatial dimensions. And so 3 spatial dimensions works well, but 2 or 1 don't work well at all. So you might say, all right, well, if 2 or 1 spatial dimensions don't work because they're too simple, maybe let's go to 4, 5, or 6 more and see maybe that makes things even better. It adds more complexity. Well, it turns out it does enable more complexity, but it comes at a cost. And one of the biggest costs is that given the laws of physics that govern the universe, when you go to 4 and 5 and more dimensions, there are no stable structures. Take, for example, a planet orbiting around a star. The way the law of gravity is constituted, that in 3 dimensions you get these nice stable orbits. So you've got, just look in our solar system, you've got the sun, and you've got the Earth makes a nice almost circular orbit. Technically it's an ellipse, but for the purpose of discussion, we'll just say it's a nice circular orbit. These things happen well in 3 spatial dimensions. If you go to 4 spatial dimensions and don't change the laws of physics, what ends up happening is that planet now, instead of making nice circular orbits, will do one of 2 things very quickly. Either it will spiral away from the star, or it will spiral into the star. Either situation doesn't allow any sort of stable planetary structures. And it turns out it doesn't apply just to planetary structures, but even when we talk about the stability of atoms, the same problem exists. So only in 3 large spatial dimensions are you going to get the stable structures, the planets, the atoms, and the things like that life requires to exist. And so in terms of changing the spatial dimensions, if we go to 1 and 2, it makes things too simple. If we go to 4, 5, 6, and more, it makes things too complex. Only in 3 spatial dimensions do we get the stable structures that life requires. So now you can ask the question, all right, we've looked at kind of how the spatial dimensions would change. What happens if we change the number of time dimensions? And so in the plot there, it's this kind of brown area, and all of those different brown areas, we ask the question, what happens as we change these dimensions, or change the number of time dimensions? Well, it turns out in those situations, in all of these situations, physics becomes unpredictable. Now you might say, okay, no big deal. I don't know how to use physics to predict things anyway. What's the big deal with that? It turns out, again, that life requires predictable physics for this reason. Life has to sense its environment. So take a bacteria. It's in an environment of some sort. Now there is a food source in one location, and there's a harmful poison in another location. Now those are going to mix through there, and so this bacteria needs to be able to sense that environment, realize that there is harmful stuff this direction, there's food in this direction, and to be able to move towards the food. Now the bacteria isn't thinking about this, but it's got processes built into the way it functions that allows it to make those senses and say, okay, if moving this way is going to lead to danger, moving this way is going to lead to food. And so by making a measurement in its immediate vicinity at its certain time, it can know what's going to go on in the future. And all life requires that. It's not just that I can predict what the weather's going to be like, but in order for life to function, it has to be able to evaluate the local conditions right now and make an assessment of what things are going to be like in the future in different directions. And so life requires predictable physics. Now there's one more set of conditions that we need to consider, and that is where we have one spatial dimension and we change the number of time dimensions. And it turns out there are problems associated with all of those, like we've talked about in terms of having one time dimension and different spatial dimensions. But there is one area where you've got 3 time dimensions and 1 spatial dimension where these tachyons can exist. There are actually particles that can exist, and they're called tachyons. Now the characteristic of a tachyon that is most relevant is that it is a particle that always moves faster than the velocity of light. Now again, if the question is not, is there some interesting physics that goes on, but is life possible? Well, if particles all must move faster than the velocity of light, you ask the question, can you build life out in that sort of system? The answer is obviously no, because for life you've got to bring particles together so that they can conglomerate and build organisms and build structures and ultimately life. Well, if everything has to move faster than the speed of light, and everything will see everything else moving faster than the speed of light, obviously there's no way that there are going to be any sort of structures in this sort of environment. So we live in a universe with 3 spatial dimensions and 1 time dimension, the single configuration where life can exist. Any other situation and life can't exist. And that's exactly what you would expect if there is a creator who is fine-tuning the universe to fulfill its function of supporting life.